වසන්ත පටන් ගන්න. වසන්ත ඇහෙනවද? වසන්ත මල්ලි
මයික් එකේ ප්‍රශ්නයක් මොකක් හරි අවුලක් තියෙනවා Zoom එකෙත් මේ. වසන්තයි ඔයා කියන දේ ඇහෙන්නේ නැහනේ.
වසන්ත නෑ නේද? ඉන්නවද? පියා
It's okay, we can start. It's
වසන්ත දිනේෂ් වසන්ත ඇහෙන්නේ නැද්ද?
එයාව ඇහෙන්නේ නැහනේ. වසන්තයි මොකක් හරි අවුලක් වගේනේ. එහෙනම් අපි පටන් ගමුද නැත්නම් වෙලා යනවනේ.
රයිට්. පටන් ගමුනේ.
okay, shall I start?
රයිට් ඕකේ. yes sir. you
Okay.
can start. and share now.
It is already shared, no? You can view that.
yes.
Right, it's not moving. Right. So in the laboratory management, it is before we go to the topic, I'll try to give an overview. So in the laboratory management, there is a management part. So in the management part, there are several roles played by the senior MLT or chief MLT or superintendent grade MLT or other MLTs. So they have separate management role they are playing in the laboratory. The one huge area is human management. That is one kind of management coming under the laboratory management. So other important area is we involved in inventory management. So we deal with management of inventory items. It may be a surgical, or it may be a general, or it may be a consumable. So all the inventory management coming under the inventory management. Another important part is equipment management. So that part is we are going to discuss here. So that part include whatever the areas we have to cover under the equipment management. So what I try to do is first we try to discuss the importance of carrying equipment and other relevant equipment management, that is care and maintenance, and if any equipment failure, what we have to do, and some calibration. So I'm not covering all the equipment, only try to cover important equipments. Right. Anybody can say why a maintenance of equipment should be done? So if we think about that, So our main role in the laboratory is we are doing several analysis and we produce results. So depend on that particular results, that result should be accurate as well as precision. So this is one main requirement for and maintenance of equipment, because all the tests are mostly depend on the modern equipments. So if you fail to maintain properly our equipments, then that will affect our results. So the accuracy and reliability is one main reason why we need to maintain the equipments. The second one is it is the purpose of equipment durability. So if you do the maintenance of the equipment in a proper way, we can utilize that equipment for a longer period. The third important point is cost effectiveness. So the preventive maintenance, that means maintenance that will help to avoid major repairs. So the durability is long. So we can save the money, or that is cost efficiency. So cost efficiency is one of the main reason why we have to do care and maintenance in laboratory equipment. The other one is to ensure the safety. If the equipment is working properly, it is safe for us. Otherwise, it may be due to electrical failure or electrical shock, or maybe any part will suddenly remove from that equipment and it will physical damage or physical harm. So those things can be avoided by doing a proper maintenance, right? There are some more. Other important is, so if we are looking to do the accreditation or any regulatory purposes, it is a requirement to maintain a document of maintenance of the laboratory equipment. So that is for credibility of our laboratory. So that is one other main reason why we need to do care and maintenance of equipments. Then the next main important point is we can minimize the equipment downtime. So it is very critical when the particular lab is handling large volume of samples and they are handling emergency cases. That time, if the equipments fail, then it is a critical situation. So to avoid that, if we are maintaining properly our equipments, then we can avoid those failures. Then next important point is we can optimize performance. So if we take analyzer or whatever the equipment, so the proper maintenance will give a good performance. So that is another important point. And for the quality management, that is a quality requirement. One of the quality requirement is maintaining the equipment properly and maintaining the maintenance log. These are very important point when we consider the maintenance of equipment. So there are about 8 points, 8 importance of maintaining the equipment. Right, we'll go to the next part, equipment management. So under the equipment management, we try to go by a few equipments, microscope, centrifuge, hematology analyzer, and biochemistry analyzer. Right. Anybody can say microscope, care and maintenance. I think you can remember during school days. So you have learned these things, but just to refresh, what we have to do when we are considering care and maintenance of microscope? Anyone? What are we should mainly consider? Hello? Microscope. So most of you all using each and every day. So when we consider care and maintenance, what are the things?
Microscope should be placed on the bench without vibration.
Right, vibration-free environment. What else?
Cover with dust cover.
Right. So we have to from the dust. So we use dust cover, right? What else?
Avoid the fungal growth of the lenses.
Yes, we have to avoid fungal growth. For that, what we can do, we have to check for the humidity and that in such a way we can avoid fungal growth, and we have to avoid direct sunlight. What else we can?
When handling, use both hands.
Right. We have to protect, right? When we are handling the microscope, we have to handle gently. So that is why we are using both hands. One hand to hold by arm, and other to support the base, right? Anything else? Right. Let's see. So, so microscope handling. So we can we do things daily, care and maintenance, and we do certain things periodically. So if you take the microscope, what is the main part? Main part is lenses, that is optic system, right? So we have to very careful about the lenses. So if there anything went wrong in the lenses, then no use of a microscope, that is already know. So we normally daily we have to clean the lenses. So we can use tissue, lens tissue, or we can use a lint-free cloth, right? So it is similar to the cloth that we are cleaning our specs, right? So that lint-free cloth is good. So we can clean the lenses. So that one maintenance we have to do daily. And for that, it is better if we are using the manufacturer's lens cleaning solution other than what we are preparing in our lab. So it's better to use the manufacturer recommended solution. And other thing is that if it is in an area where it is affected by the dust, right? So we have to daily clean the other parts of the microscope, like stage, body, right? If there are any spills occurs, we have to quickly clean it, right? And these things, that is, we are not touching the lenses by our fingers, right? So that's why we hand lens or the soft cloth. And when we are storing the microscope, we normally turn off the microscope. That is, we have to do it, but we are not doing removing the flag, right? We have to remove the to protect the microscope from the environmental factors. And we discuss, you have told that dust cover, we have to protect from the dust. And the place. We have to store in a place to avoid direct sunlight as well as excessive humidity, right? Then mechanically, when we are handling, we have to do certain cares. That is what this point you have told. You have to handle gently, right? Yeah, that means you are using both hands, right? Right. And another point is when there's a difficulty to turn the knob or turn any part of the microscope, moving part. So we should not use force, right? If you use force, it will break down. So we have to avoid using force. And again, we can lubricate the moving part, right? It says every 3 to 6 months, but at least once a year we have to lubricate the moving parts. Right, that is lubricant also we have to check for the manufacturer. The manufacturer recommended lubricant should be used. Right, so movable part, there are particular knobs, focusing knobs, mechanical stitch moving knobs, right? Then electrical care, about that we have to check the cable and we have to check the bulb, and if it is burnt out we will replace it. When we are replacing it, we have to use the correct type of bulb, right? And if our electric supply, power supply, voltage is fluctuating, that means it is not stable, we have to use a regulator or voltage regulator to ensure the stable power supply, right? And other main thing is at least once a year, we have to do get professional services. That means not doing by us, we do by a well-trained biomedical engineering engineer. So he can do the a thorough service, right? So if there are any damage or any fault, we have to enter in the maintenance log, and we have to go for the technical support. So these are the main things relevant to microscope. So that is, in microscope, it's simply you can write even in the exam. Next one is the centrifuge. It is also one of the only used equipment. The centrifuge, again, we can say daily cleaning and periodic cleaning. Can you say something about centrifuge, how we can care and maintain? What is the main part of the centrifuge? The rotor is there. It is the main part. And buckets are there. And the chamber is there. Right? So there's a lid. There's a lid. So when we are continuously using the centrifuge, there may be chances of breakage of tubes or spilling of the material, infectious material, and it will get dirt in the chamber. So we can use a different kind of detergent to clean that, and we can use certain alcohol to decontaminate the centrifuge. So the detergent and decontaminant are two things. That detergent is to remove any dirt, grease, or any stain. That is, we use detergent. And alcohol we use to avoid the spill or disinfect the centrifuge. So when we are using this any detergent, it should be neutral pH. Otherwise, it will damage centrifuge itself. So this RBS 35, it is supplied by the ministry, right? MSD. So that is good cleaning for instrument. So that is laboratory grade detergent. It is enough to clean the chamber of the centrifuge as well as the rotor, right? Or any other detergent that is neutral pH and mild detergent is better, right? Otherwise, it will damage the chamber and buckets. And after cleaning, we have to dry it using a clean cloth, and we should not use any abrasive cleaners or acid or bleach, right? And that is daily cleaning. So it is you have to remember this: the RBS 2% is suitable detergent in our environment. And when we are considering this rota, we have to check rota, and if there are any damage, right, we can replace that. And other main thing is it is normally we do that we have to balance before we start the centrifugation, right? Otherwise it will cause vibration. And there are inbuilt system in the centrifuge, so it is a protective measure which will not start until the things are balanced, right? In both sides, it should be tubes should be in a balanced way, right? Right. Another important thing is the operation and the balancing important, as well as overloading also important. If you overload, then it will not work in modern centrifuge, right? So we have to follow the guidance. And again, the lid should be locked, right? If it is not locked, it will not start. And there are certain centrifuge when we are operating manually, which can open even when it is rotating. So that should not be done because the aerosols is coming out. So we have to wait until the speed becomes 0. And again, the centrifuge, the mechanical part is rotating, and we have to lubricate that particular rotator. So again, at least once a year, we have to do thorough service by a professional trained biomedical engineer. And when we considering this safety regarding electrical safety, again, as well as for the microscope, we have to check the cable and this, as I told, this imbalance detecting system. Right? There are in some centrifuge inbuilt imbalance detecting system. So if there is an imbalance, it will give some signal, some signal. So we can, so we know it is imbalance, right? Right. So microscope as well as centrifuge, these are very simple equipment in our laboratory. Spectrophotometer is one of the other important equipment, but nowadays most of the laboratory not using spectrophotometer. They are using spectrophotometer, but that is not as a spectrophotometer. That spectrophotometer is inside the biochemistry analyzer. So it is there inside the biochemistry analyzer, but we are not using, most of the time we are not using spectrophotometers separately. But certain hospitals laboratory, they are using spectrophotometer. Next we go for the spectrophotometer care and maintenance. It is very simple. It is same for other equipments. We keep on a bench, that is vibration free is very important, and it should be away from the direct sunlight. As well as we have to do calibration, wavelength calibration, and we have to check the stray light, and we have to do the absorption calibration, and we have to maintain a logbook, maintenance book. So because there's a limited time for the light source, and we have to operate that equipment in a such a way, spilling the chemicals inside the spectrophotometer. And other things, you all know, we zero it and we use the blank and all those things. And we have to do the calibration before operate the spectrophotometer. So then we go for the hematology analyzer. The common things we have to consider a hematology analyzer is when we are using hematology analyzer, we have to use the controls which are approved by the manufacturer or which are recommended by the manufacturer. That is very important because they have built in a such a way that will to use their reagents and their controls, right? So sometimes other reagents or other control may reduce the durability of the analyzer, right? And store as per the manufacturer instructed. So one main thing we have to consider is when we are purchasing the this analyzer, we have to get the user manuals. User manual, it is normally supplied, but if it is not there, we have to get it. So because everything regarding that analyzer is in the user manual, right? And we when we are shutdowning the this hematology analyzer, we have to go according to their shutdown protocol, right? We can't quickly switch off. We have to go that particular shutdown protocol, right? It will automatically run. And we have to keep clean and dust-free environment, and we have to maintain a maintenance log. These are the common things, not only for the hematology analyzer, but also for the biochemistry analyzer. And so you're all using hematology analyzer in your hospitals. So can you say what are the daily maintenance, daily care and maintenance? What are the periodically care and maintenance you do in your labs? You must know better. Anybody, you all operating hematology analyzer? What are the things daily you do?
Probe cleansing,
Sorry, I couldn't hear.
probe cleansing,
Can you explain a little bit? Hello? Any other points? So what you do regarding hematology analyzer for daily care and maintenance. So you're operating daily. most of the things are automated. We have nothing to do manually. There are only few things we have to do in manually. Anybody else? Hello? You can hear the command, I think. Somebody is trying to say something.
The prop cleanser is used to clean the prop, because if there is any clots or something, it will if you unable to delete the error, it will guide a very big problem to the machine. That's why we are
Probe is very important part, because the probe is used to take. So sample we are using blood. So there is always there's a possibility of formation of blood clot or protein buildup, or those things in the probe. So if the failure in the probe, the correct volume will not be aspirated, or there's a problem in aspiration. So very important, we have to clean the probe. Right? We can do it manually or automatically. We can clean it. What else?
We have to maintain the reagent level.
We have to maintain the reagent level. So
As
if we
well as,
fail to maintain, what will happen?
some parameters will not be given in the test results.
Yeah. Oh, that means our
Accuracy
accuracy.
checking, yes, accuracy
Sorry?
checking can't be maintained. We can't take reliable test results in case of
Yes.
lack of reagent.
Yes, our accuracy will be affected, right? If the reagent level is not maintained. What else?
In addition, discarded material should be discarded promptly, otherwise contamination may take place, and malfunction also.
Right. Right. So there's a drainage, so all the waste should be go to that particular container.
Yeah.
If it is filled, we have to discard it, right? Otherwise, the machine can stop, right? Sometimes it can stop. What else?
Surface cleaning.
Sorry?
Surface cleaning.
Surface cleaning, yes, very important, right? Because even we don't think about this dust, but these are very dangerous, right? Dangerous particles are dust, which
False
can,
positive results.
yeah,
That
that can go inside, that can be aspirated, or that will even not good for the machine durability, and that will affect our results also. So we have to clean the surface, and most important, we have to keep the machine in dust-free environment. That is a very important thing. What else?
There should be a way of checking reagent, because sometimes some reagent may contaminate with bacteria and other fungal contamination.
How you can check those things?
You can check. You can use culture procedure even, right? So sometimes even
right. Quality is talking about quality of reagent.
Yes.
So that is very important. So we can that should be started from where we get it from the reagent, right? We say if we are getting directly from company, so for the company maintain this cold chain, right? And we have to store in a proper way. So storage temperature, storage condition is important for the quality of the reagents and the calibrator as well. So that in that situation, refrigerator or the place where we are storing the reagent, also we have to check whether it is we have to calibrate that equipment. If we are keeping the refrigerator, we have to check that temperature is okay, whether our fridges are calibrated. So the storage condition is important to maintain the quality of reagent. Right. What else?
Never ever use expired reagent.
Right. So we never use expired.
Even this machine mostly follow cooled technique. There should be a check-in way of voltage check-in and everything have to be supervised by the manufacturer in case of malfunction.
Right. Right. Okay. That means whatever any problem occurs,
Yes,
we have to
voltage.
contact.
Yes, voltage impedance errors.
Right.
Right.
Voltage.
Yes.
So there should be a voltage. What else? What about the distillation? Distilled water supply.
Yes, it should be checked because now washing purpose of
Those things are we have to check manually, right? So the wastage as well as the distilled water supply, and if there any problem occurs, we have to directly contact the manufacturer, supplier, or the company to correct it. We should not try ourselves without knowing what is inside, without knowing the proper technique, right? Okay. Any other points?
some sophisticated analyzers use different parameters for evaluation of particular condition. For instance, retic count and others, in which we have to use different stain. We have to consider the quality of stain the manufacturer will providing to the machine. Those should be regular check.
Right, that is internally done.
Yes.
Internally built system.
Yes.
So that is this auto analyzer, this biochemistry analyzer as well as hemorrhage analyzer. So it is mostly the instruction we have to follow according to the manufacturer. So there are many varieties of equipment. So we have to stick to that one, right? So we can't give a common procedure for all the analyzer. Right, so it is very specific for the particular analyzer. There are differences. Right, so there are inbuilt system to check quality of the reagents as well as other fluids we use. Right, so there are few things I just put it. So these are we discussed. You have bring out. So this is in a daily task. These things are it is automatically happening. Prime the analyzer. It's run, right? So when you start the machine, it automatically will do. So this is the purpose is to remove the air bubbles in the tubing and reagent lines, right? That is the first. And when it is the startup program or shutdown routine, so it is inbuilt system, so it will do the necessary cleaning, do the necessary things before it start down, right? So it is very important for the stability as well as the healthiness of the equipment. And the probe, yes, you have told that you told me that cleaning is very important because it is where we aspirate, the samples are aspirated. So we had to do it daily, right? So to prevent blood clot as well as protein buildup, right? And we have to run QC. That is important to ensure that accuracy is there, right? So if anything went wrong, how we can detect? So we can detect by QC, right? So if QC is out of range, something wrong, right? And as we discussed, we have to check for the waste container and as well as reagent level. These two are very important. So that to prevent the system we have to check these things. So we have to remove the waste as we have to fill the reagent. And we have to check for any unusual noises or any leaks. Right? We have to check whether there's any leaks or unusual noises. Then we have to contact the relevant party, right? So if we can detect early, we can minimize the cost of repair, right? So if we can detect early, we can correct it, right? Then there are something we do a weekly task, right? So that is cleaning sample probe with enzymatic cleaner. So that means deproteinizing solution. The enzymes, it's contain protease. So it will remove all the particle bound to the probe. And we have to inspect the reagent tubing and connection. So if there are any leaks or blocks, we can change that, right? And as somebody told me that we have to clean the surface, exterior surface, and screen to reduce the dust and contamination. Right, and there are certain things we have to do monthly or periodically. Normally, we don't do monthly, right? So every 3 months or once a year or every 6 months, periodically we can do that. Certain tubing and filters, we have to replace it, right? After a certain time, we can't continue using the same tubing. And internal cleaning cycles, that is a very deep cleaning, right? Deep cleaning, it clean the chambers also, chambers. So that is also we have to do periodically. And we have to do full calibration periodically to ensure the accuracy, right? And we can again check the internal components, right? To prevent the hardware failure. So these things sometimes we can't do, right? If a professional trained person can do, check the internal components. Right, a biochemistry analyzer also similar, right? There are many things common. So I think I need not to repeat these things because the same thing, right? Almost same. So I'll share the PowerPoint presentation. You can go through it. There are some differences, right? So here there are cleaning sample probe is there, reagent and waste level also there. Everything is same, right? There are some few differences. That is the cleaning cuvettes and mixing chamber. These are the new things, right? So I just go. And then the other part, next part, documentation of equipment. So in management part, it is very important. So we know now we discuss certain equipments that we do daily and periodically maintenance. But this part we normally don't do in our laboratory setup. We are not documenting our maintenance of the equipment. So, so we have to make sure the documentation is very important. It is helpful for us also. Right. So as I told earlier that the user manual, we have to get it from the manufacturer or supplier. That is very important because it's give installation procedure as well as other things need for the user. And we can also prepare standard operating procedure using user manual and all other things. We can, in a shortened form, we can prepare it. So we can, if we prepare the SOP, we have to keep one copy at the site of the equipment and another copy in a master file. So if we take a maintenance logbook, so we can maintain a CR book, right? We can maintain a CR book for each equipment. So in that logbook, these details should be there. So name of the instrument, the model, serial number, inventory number, date of purchase, right? Who are the manufacturer, the local agent, their address, telephone number, email, and we can add certain things like this warranty period is there, from which period to which period. If there is service agreement is there, then we can also put it in that, maintain in that book. Service in how long, and how long it is free service, how long it is on the part replacement. Likewise, everything should be entered in a book that is called the maintenance logbook. So if you want to know equipment, or if anybody in the lab want to know about the equipment, just go through that particular equipment maintenance book. We can know everything about that particular equipment, right? And we can, if we do this maintenance, we can record those things. We say, especially if you do the periodically maintenance, we can enter that. If we change certain, or if we replace certain part, so that should be entered in the particular book, right? So in other countries, there's a supervising system, there's a supervisor. He supervise whether these things are happening regularly, right? And if we do any repair, so we have to write it, the nature of the repair. And if you do the calibration, we have to write the date and what are things calibrated. All these things should be included in the maintenance book, right? So it's a very important. We have to separately maintain a maintenance log or maintenance book for each and every equipment in the laboratory, right? So if any equipment is malfunctioning, what we have to do is, we should not try to open that, because we have to first check whether there's a warranty period. So if the warranty period is there, we can replace the total equipment, right? So that is why if we are maintaining a logbook, then we know a particular equipment, particular serial number, particular model, what is the warranty period, and what are their conditions. Everything is there in the book. So it's easy for us. And if the warranty period is over, and if there's any service agreement, then we look for that, how long. We can contact the servicing party or the supplier. We can do the sales, right? So if we say, if the sales agreement also the time is over, then we can contact the agent. So if you know the agent, that is in the maintenance book, so we can contact the agent and we can get done the repair. So that is the best way to do that. So if these things are not available, so we can use check our biomedical engineering service. So we contact them and we can try to repair the instrument. That is basically surgical equipments. The other equipments, general items, we can, if there are maintenance unit in our institute, we can go for that. That is, if the warranty period is over, if the sales period is over, and if we can't do it by the particular supplier, right, then we can go for that, right? Then the other part is calibration of equipment. So we go through this. So few equipments: spectrophotometer, centrifuge, micropipette, balances, autoclave. Right. Can anybody say what are the things we have to calibrate in this spectrophotometer? I just told you, right, when I'm discussing earlier, I just told you what are things we have to check, calibrate in the spectrophotometer. 1, 2, 3. Yes, anybody? Hello.
Balance.
Sorry.
Balance.
Spectrophotometer. I'm talking about spectrophotometer. So,
Wavelength.
wavelength calibration, right? What else?
They have to consider even like
Monochromic light.
Monochromatic. We can monochromatic light. In other way, we can
Filters.
say we
Filters.
are we are checking for the stray light. We
Hmm.
check for the stray light. Right. What else? Other thing is absorbance. Right.
Absorbance.
So we go one by one. Right. So normally, this is I discuss finalize, right? Spectrophotometer. We normally use when we are calibrating spectrophotometer, we normally use the potassium dichromate solution. So this, why we are using this kind of solution is because this solution is stable. That is the one thing. And the absorbance of this solution is predictable. In certain wavelength, it is predictable. And it is traceable to standard like NIST. Right? NIST means National Institute of Standards and Technology. That is in USA. So they are standardizing organization. So that is why we are using the potassium dichromate. So right. So the first one we check in the spectrophotometer, okay, we do calibration, that is wavelength accuracy. So wavelength accuracy, it is like this. So if this potassium dichromate solution, the concentration is 50 milligram per liter. If we take this solution and we use this sulfuric acid, 5 millimoles per liter to blank the instrument. And if we take the solution and if we get the absorbance reading, right? So we will get, right, peak reading at 350 nanometer and 257 nanometer. Right? If you go to the, you can see. So here 257. So you get the peak reading and 350 also 2 peak. So this is one kind of calibration. If you are getting peak reading at 57 and peak reading at 350, then we consider the wavelength is accurate, right? So what we do, the same solution, we take reading at different wavelength. So when we are taking at different wavelength reading at 350 and 257, it should give a peak reading, peak absorbance. So in the spectrophotometer, there are certain spectrometer, it is, you can run wavelength scan. So it automatically take, we can give the instruction at what wavelength you have to take and what is the interval. Then it will automatically take the reading and give the graph. So we can check whether that peak reading is coming at this particular wavelength. So that is wavelength accuracy. The other one is we check photometric accuracy, that is absorbance accuracy. That is also very much similar. So in the same solution, this potassium dichromate solution, it should give about 0.535 absorbance reading at 350 nanometer and 0.72 at 257 nanometer. So there's a range given here. So if within that particular range, so we can think that we can make a judgment how accurate our absorbance is. If it is very close to this range, that means our spectroid is okay. Otherwise, we have to do the adjustment. We can't do manually, but the particular professional trained persons have to do that. Right. Then stray light calibration. Stray light, I think you have understanding what is stray light. The stray light means we say, for example, in the spectrophotometer, we are selecting a particular wavelength. So we are selecting the wavelength that the particular wavelength will be absorbed maximally by that particular solution. right? So that is why the wavelength is differ for different solution. So if all the light coming from the monochromator go to the detector, then we say it is 100% transmittance, right? It is 100% transmitted, right? So what we can do is, if any other lights coming other than monochrome to the detector, we call stray light, right? If the light come from the light source and it go through the monochromator, and that selected light go and touch the detector, that is what we are expecting, right? If any light coming from other sources, then we call that is stray light. So if the stray light is minimum, then it is that is what we want, right? Right. So this one can be checked. So we use sodium nitrite solution. Sodium nitrite solution, 5 gram per deciliter. So this is we call blocking filter, right? So we select the 340 nanometer and we keep the distilled water as a blank. And at 340 nanometer, we set the transmission to 100%, right? So 340 nanometer is the wavelength. We keep the distilled water in the cuvette, right? Then we set the transmittance to 100% transmit, right? After that, we put this sodium nitrite solution. Actually, the transmission should be 0, because this sodium nitrite block all the wavelength, the light at 340 nanometer, right? So if this sodium nitrate solution is blocking that 340 at 340 nanometer, then no light will touch the detector, go to the detector. So if any light detected by the detector, that is stray light. So so that should be less than 0.1%, less than 0.1%. I think you have understood. Then centrifuge. Centrifuge, these are 3 parameters we calibrate. One is the speed, RPM, round per minute. Other one is timer, right? We normally in a centrifuge, we set speed as well as we set for the time, how long we want to centrifuge, at what speed. So that both things we set in the centrifuge. And if it is a refrigerated centrifuge, we have to calibrate for the temperature also, right? So in blood bank and other things, they use refrigerated centrifuge. And these two, speed and time, so we can speed, we can use tachometer, right? Tachometer is to measure the rotating speed. So this is done. What we can do is we can set the speed at centrifuge, and we can start running, and we can connect the tachometer, or we can focus to the rotor. So that tachometer will show the real speed once it is come to the stable speed. And we cross-check with the speed shown by the centrifuge and the tachometer. So ideally it should be both same, right? So if there are any problem, if there are any deviation, we have to adjust the centrifuge speed in the panel of the centrifuge. So that is as it should be done by the professional trained biomedical engineer, right? But we can check it. We can check it whether our centrifuge is rotating at the particular speed. Right, our tachometer should be certified one, right? Otherwise, we don't know the problem is in the tachometer or the centrifuge. Right, so it is we can check for the low point and medium level speed or low speed or whatever the high speed. So significant difference, we consider if it is the difference is more than 1%, we consider as a significant difference, more than 1% difference, right? So that time only we have to adjust the centrifuge speed. And the timer, it is easy, you know, if we have a certified timer, we can set the centrifuge for, we say 10 minutes or 5 minutes at a particular time. And we start simultaneously both the timer, the certified timer, as the centrifuge. And centrifuge should stop at particular time. So if it is not stopping, if the time, both times there's a deviation, again we have to correct that, right? For that also the timer should be a certified. Right. Then right. Okay. Right. Micropipette calibration. So do using a balance. So here important is the balance should be on a stable place, and this free draft means no airflow, and the humidity also given, the temperature. So humidity should be 50 to 70. Oh, we can do that, right? So what we have to measure the temperature of the water, distilled water, what we are going to use for the calibration. And we know the density of the water at 20 degrees Celsius, right? So we have to do necessary temperature adjustment. If you are doing at 20 degrees Celsius, it's okay. So we use pipette tips, new pipette tips. And before we spread the this distilled water, we had to 2 to 3 times by drawing and expelling. And we had to do is spread the water in a slow manner, right? To avoid any air bubble trapping. And we can measure the weight or mass of the water each time. So at least we had to do 10 times. Then after that, so now we know we can calculate the mean, we can calculate the standard deviation, and we can calculate the inaccuracy. So the volume is given, so we know that we can measure the weight. So we know the weight, we know the density, and we can calculate the volume, right? So we get the mean measured volume and nominal volume. Nominal volume means, we say if we are try to calibrate 100 pipette, so the nominal volume is 100 microliter. That is the volume we are expect to delivered by that particular pipette, right? So we find the difference, and we find the inaccuracy, how inaccurate, right? And we can find the precision also. So if we can find the standard deviation, and we know the mean measured volume, and we can find the precision also. So this is the acceptable accuracy and precision according to ISO 8655. So if the pipette volume is 1000 microliter, accuracy plus or minus 1% is accepted, right? That means you can see 10 microliter difference, right? 990 microliter to 1010 microliter. In that range, it is accepted, right? So if it is 100 microliters, it is 1.5%. If it is a 10 microliter, it's a 5%. Right, 5% means we can say 0.5 microliter. That means 9.5 microliter to 10.5 microliter is accepted range. Right, so that is this calibration of the, and the other one is the calibration of analytical balance. So analytical balance, if you see, there are calibrated or certified weights are there. So in USA it is NIST, that is National Institute of Standards and Technology. But in Sri Lanka, SLSI, Sri Lanka Standards Institute, they take the responsibility to issuing the this certified weights. They do calibration also. Right, so again here we need a level surface, and draft-free environment is important. So normally whatever the equipment we on 30 minutes before to warm up, and balance should be very clean and on the level surface, and we have to zero the balance and we can start the calibration. So most of the calibration balances is do internal calibration. That is, we need not to keep this standard weights to check the weight. Once you press the calibrator button, it is internally, it will take time to calibrate that using an internal weight, right? So once it is finished, it will give the zero reading. That is internal built-in calibration. The most of the nowadays balances are built with built-in calibration, right? Or those, even those balances can be calibrated, or we can check using a weights, right? So we can zero the balance, and we can using the standard weights, and we can we check whether it is giving the right accurate reading, right? So we can use the low level as well as a little bit high level weight also to check any deviation. Right. So the autoclave, if we consider the autoclave, here also there are three parameters we are calibrating. One is the temperature, other one is the pressure, other one is time. Timer, as we did for the centrifuge, we can check the time. And the temperature, we have to use a temperature probe, right, or thermometer. We have to keep inside the autoclave, and there should be mechanism to register the temperature changes, right? As well as we compare the display of the this autoclave, and we see any deviation between those readings. So if there's any deviation, we have to recalibrate, right? So we have to find out the actual temperature. So when we are using this thermometer probe or thermometer, it should be certified thermometer. Then only we are sure we are comparing with our autoclave temperature with the certified thermometer. Right. Again, it is 1%. 1 degree Celsius difference is permitted. Right. We say if we set to 121 degrees Celsius, if the temperature reading is 120 or 122, it's okay, right? So if it is more than that, we have to do something to make sure that it will attain the correct temperature, right? So the pressure also, we have to use the pressure gauge and deviation, right? So that is I'm not much go through that. So the temperature is important, and do the validation, sterilization validation by, you all know that Stereothermophilus spores is the organism used to check the sterilization. So that is what we want. But the calibration is, we do these three parameters: temperature, pressure, and time. So that's all about regarding this equipment maintenance, care and maintenance. So anything you want to share? Or any feedback?
Shall I ask a question? Hello.
Hello, tell what you.
In case of autoclave efficacy, right, temperature efficacy, there are some strip too, no? Chemically
Yeah.
reactor. We can use those strips to check whether temperature is okay or not. Are using probe?
It's okay, right? It's okay. We can check that, right? So it is. We have to make sure that strips are reliable.
Yes,
It
potential
is coming from the proper sources, as well as it is certified, right? So then it's okay. So we can do any, right? So what we want is to make sure that it is at the correct temperature when it is while it's working. I don't know whether the session is useful or not. Just refreshing you. But there are many details. I didn't go very detailed. There are some other equipments, the pH meter and those things. I think those are you all using daily, so it's not needed to talk very much about that. In regarding the pH meter, we do calibration. There are 3 points. One is 1-point calibration, 2-point calibration, 3-point calibration. So normally 2-point and 3-point calibrations are recommended. That is, we calibrate the pH meter at 2 level. We say at low level, we say around 4. One is around 7, 4 and 7. That is, we do 2-point calibration. So 3-point calibration, we do 2-point calibration plus a higher pH, around 9. So that is based on our requirement. If we are going to measure the pH acidic solution, we go for 2-point calibration. Okay, we calibrate at 4 and 7. If you are going to read for the this alkaline pH, then we go for 3-point calibration. So, and again, the pH meter, there are variation based on the model and the company. But so the electrode is main thing we have to care about that. That is, if we are not thing, we have to keep inside the this salt bridge. That is mostly we use potassium chloride. And it should not let it to air dry. So it should, when we are storing, we have to keep inside the potassium chloride solution. And again, the maintenance thing is depend on the product. Hello. Anything if you want to share to others, you can share it. So it is sharing your knowledge. Hello.
Hello, thank you, Mr. Hunais,
Yes,
principal of the School of MLT, Peradeniya. Thank you for your valuable support for conduct our online replacement training. I think one part there, no, laboratory safety procedure.
Laboratory safety is there. So another 1.5 hours.
I think I will discuss with you. I will
Oh.
give time for next week, right?
Okay, thank you.
Right, okay. Right, thank you.
Thank you for listening.
Right, thank you for all of you. Next, let's just continue with histopathology modules. Wednesday, Thursday, and Friday. Right? Right, thank you for all of joining with us.